Good morning, everyone. This is Agnapriya from CSE section from Srinivas Ramanjan Institute of Technology. Today, I'm here now you to discuss about the topic of drift and diffusion currents in engineering physics. Let's go into the topic. Drift and diffusion currents. Introduction to drift and diffusion currents. Drift currents and diffusion currents are fundamental concepts in semiconductor physics. In semiconductor physics, these are the fundamental concepts. Understanding these currents is crucial for analyzing electronic devices' behavior. This presentation will explore the definitions, mechanism, and application of both current types. In this video, we are going to know about the definitions of these particular thing and mechanism of these different diffusion currents and applications of the both current types. Here we go the picture of drift currents. What are drift currents? Definition of drift currents. Drift currents is the flow of charge carriers due to an applied electric field. It is proportional to the electric field strength and the charge carrier mobility. Drift currents are significant in semiconductors where they dominate of high electric fields. What are diffusion currents? Diffusion current arises from the movement of charge carriers from regions of high concentration to low concentration. This phenomena is driven by concentration gradients and it is described by Fick's laws of diffusion, which is we can see in physics. In semiconductors, diffusion currents are important in process like recombination and generation. And next, mechanism of drift currents. When an electric field is applied, charge carriers experience a force that causes them to move. When we apply an electric field to them, a charge carrier means electrons experience a force that causes them to move. They ready to move. Electrons and holes in semiconductors contribute to the overall drift current. Here's the image I am showing you. The mobility of carriers determines how quickly they can respond to the electric field. Here the mobility of the carriers determines and describes how the electric field is going to respond. Mechanism of diffusion currents. Charge carriers spontaneously move to achieve an equilibrium state in response to concentration differences. The diffusion current is influenced by the concentration gradient of the carriers. It plays a critical role in the operation of p-n junction and bipolar junction transistors, p-n junction diodes, in transistors, in solar cells. It very useful. Mathematical representation of drift currents. The drift current density, which is denoted by ZD, can be represented using the equation ZD equal to Q. It is equal to the charge carriers. And next, mathematical representation of diffusion currents. The diffusion current density Z diff can be represented as Z diff equal to minus D. dN by dx, where d is the diffusion coefficient. The diffusion current is equals to the negative sign of the diffusion coefficient. This equation emphasizes that diffusion current flows from area of high to low concentration. Now here we are going to discuss about the differences between drift and diffusion currents based on their features. First one, definition. Drift currents caused by the movement of charge carriers due to an applied electric field. And in diffusion currents, current caused by the movement of charge carriers due to concentration gradients. Here, the movement of charge carriers is done due to applied electric field, and here it is done due to concentration gradients. And the driving force. Driving force is due to external electric field in drift currents, and it is due to carrier concentration ion gradient. Direction of drift currents is for electrons is in opposite direction for holes, and in this diffusion currents it is from higher concentration ion to lower concentration ion. And what is the expression for this? What is the equation of drift currents? Is ID equal to Q and mu into EA for electrons. What is the expression or equation for diffusion currents? Is IDF equal to small q into capital D into small d n differentiable of dn by dz into A. And what is the carrier type? Both electrons and holes. And for this also, the carrier type is same as like both electrons and holes. Proportionality. Proportional to electric field, and it is proportional to concentration ion gradient. What is the significance? Dominates in electric fields, and it is significant in semiconductor devices like PN junction diode, G0 diode. And next one, okay, now we are going to discuss about the applications of drift and diffusion currents. In drift currents, the widely used applications are transistors operations, diodes rectification, solar cells, semiconductor devices, MOSFETs, electrophysiological studies. In physics, Ohm law was that semiconductor physics like that. First one, transistors operation. Transistors operation and diode rectification. Drift current is crucial for understanding the operation of transistors and diodes, where the movement of electrons and holes within the material essential for switching and rectification. And also, the drift currents are also used for PN junction. Drift currents plays a key role in the formation of depletion regions and the flow of current across PN junction. Next, like that in solar cells and semiconductor device designs, MOSFETs, and also like in physics, Ohm law. Drift velocity, the average speed of charge carriers, is directly related to the overflow and can be used to explain Ohm's law. Like that. And next one, diffusion currents. In diffusion currents, how the applications we use. The widely used applications for diffusion currents are semiconductor devices. In semiconductor devices, diode and transistor function, solar cell efficiency, LEDs, like more, etc. In semiconductor devices, the first one is diode and transistor function. Diffusion currents plays a key role in the operation of diodes and transistors, enabling the flow of charge carriers across junctions. Next one, solar cell efficiency. Diffusion currents are essential for the generation of electricity in solar cells, where light creates the electron hole pairs that diffuse to the PN junction and generate electric current. Next one, LEDs. In light emitting diodes, diffusion currents transport charge carriers to generate active region where they recombine and emit light. Next one, biological systems. In biological system, diffusion currents plays a vital role. In that one, gas exchanges means respiration. Diffusion currents facilitate the exchange of oxygen and carbon dioxide between the lungs and the blood stream, and between the blood and the tissues. Next one, nutrient and waste transport. Diffusion currents are involved in the transport of nutrients and waste products across cell membrane and through tissues. Next one, drug delivery. Diffusion principles are used in developing controlled release drug delivery systems where drugs are released gradually through diffusion across a membrane. We are very well known the drug delivery is due to diffusion, right? Next one, osmosis. Diffusion currents are involved in the movement of water across cell membranes, a process known as osmosis. Next, now we are came to conclusion. Drift and diffusion currents are critical for understanding charge interdynamics in semiconductors, diodes, like that. Their interplay influences the performance of a wide range of electronic devices. By using this drift and diffusion currents, we develop the electronic devices a little bit or more than. Next one, mastery of these concepts is vital for advancements in electrical engineering and technology.